of the ripple
Yes, sir.
time.
Yes, sir.
Okay. So as you can see, like here, if a point source will be hitting the water, then the circular wave fronts will be formed, right? On the other hand, if let us suppose you have a container, right, where the water is filled in the container, and I can draw some 3D image like this, and here you have water like this. Okay, and now if any source like this will be hitting the water at one end, then what will happen? Based on its frequency, how many times in a second it is going to hit the surface of the water, based on that there will be some frequency, right? Yes. And now there will be some wave fronts seen. You will be able to see some wave fronts. You have seen the video already, right? And if the energy is given by this point from here, the energy will be moving in this direction, and these will be the wave fronts, right? So here this distance and this distance will remain same, lambda lambda. Now here the depth of the water is equal. Here depth is this, and here also depth is same, right? But by chance you keep some slab, some glass slab in the water. If you keep a glass slab inside the water, and let us suppose you have kept it like that, okay, then what will happen? Here the distance is d1, and here the distance is d2. So here the water is shallow and here the water is deep, right? Do you understand what I'm talking about?
Yes, sir.
In this situation there will be change in the wavelength. We will be talking about that, right, in the part of refraction. So it is a kind of refraction. Okay, now here you understood what are the wavefronts, what is the wavelength. These are circular wavefronts and these are parallel wavefronts, right? The wavelength will be the distance between two consecutive wavefronts. Is it clear?
Yes, sir.
Now the scenario for the diffraction is, let us suppose few parallel wavefronts are there. So control A, sorry, I will take the help of these grid lines so that I don't do mistake in the distance part, right? Draw shape. These are parallel wavefronts, right? And you know how you can create parallel wavefronts, right? Yes or no?
Yes, sir.
Yes.
You know the speed of the wave will remain fixed in one medium, then based on its frequency, how many times it is going to hit the surface, v is equals to f lambda, right? Velocity of the wave in a medium will be fixed. Now if you are having higher frequency, then wavelength will be less. If you will be having lower frequency, then the wavelength will be high. So if it is hitting more number of times in a second, then these wave fronts which we are drawing right now at this distance might reduce. Yes or no?
Yes, sir.
Uh, this distance, might reduce to this if more number of oscillations are happening, right? And if very, very less number of oscillations, then the wavefronts will be like that, correct? Once you
Yes,
hit,
sir.
wavefronts got created. Other time you hit, wavefront got created. Frequently you are hitting, wavefronts will be very close. You are taking a lot of time to hit, then the wavefronts will be comparatively very high. Understood?
So,
So
Right.
complete dependency. Yes, beta.
so, but it's V is equal to F into lambda. So, sir, as the wavelength increases, the velocity should also increase, right? And as the velocity is decreasing, the wavelength should also decrease.
In a medium, the speed of the wave will remain same. That's what I'm saying. V is constant. V cannot change in a medium.
Okay.
Speed of sound in water is 1500 meters per second, right? That is not going to change. Do you
Okay.
understand?
Yes, sir.
Okay. Now, these are our wavefronts. Okay. And let me shift it a little below over here. And now these wavefronts are going and it will continue to move. It will continue to move in which direction? What is the direction of energy? The direction of energy is this. And wavefronts will always be perpendicular. Yes or no?
Yes, sir.
With the help of circular wavefronts, I told you this, right? That where the energy is going in all the directions equally, and wavefronts are circular and it is perpendicular to the wavefront. Now here you are giving the disturbance on the left hand side, energy is passing on the right hand side, and the wavefronts from here it is moving in this direction, right? So the direction of energy is this, and the wavefronts are perpendicular to it. This is 90-degree. It will continue to move like this, but by chance, you if you got an obstacle in between, let's suppose you, excuse me, I don't know what's happening. अब सीधा नहीं बनेगा. This is a wall. Let's suppose this is a wall. What will happen now? Hello.
Sir, it will get reflected and go the opposite direction.
Excellent. It will get reflected and the energy will transfer in opposite direction, right? Very nice. But instead of that, instead of a complete wall, if I am going to give you some gap, this isn't working. I don't know. So I gave you a gap. Here a gap is there, right? So what will happen? It is going to stop the energy till here and it will stop this energy, right?
Right, sir.
Yes, sir.
But what about this portion?
So it will pass through.
It will pass through.
It will pass through. Yes, it will pass through. Very good. So when it is going to pass, then do remember few small things. Green, yeah. Okay. This is green. I'm closing and I will share again. Huh? Is it visible?
Not yet, sir.
Is my screen visible? Not yet?
Yes, sir, it is now.
Okay, let's see how it responds. So in this portion where the gap is, energy will go as it is. Okay, in this portion, energy will move as it is. And there will be no change in the wavelength. Wavelength will remain fixed, equal as it was before, right? But at the corner, what is going to happen? So here, the direction of the energy is this only, right? But at the corner, what will happen? At the corner, wave is going to bend. It will bend like this. It will bend like that. It will bend. And while bending, do remember one thing, that the wavelength should not change. Means the distance, this distance lambda and this distance lambda should remain same as it was same over here. Understood? Yes or
Yes.
no?
Yes, sir.
Now, here the direction of energy is this, and here the direction of energy is this, right? Again, you can say 90-degree, this one. So bending of the wave is called diffraction, right? This is one example of diffraction. Another example. So here, what is the same? Wavelength remains same. This lambda will be equal, right? At every point, and in the gap it will go straight, and here it will bend. Now, one very important thing is, so it's a rough diagram. 1, 2, 3, 4 wavefronts are there, and then I'm creating a kind of a hindrance, right? And if the hindrance, here you can see this length is approximately equal to this length, right? Yes or no? This distance and this distance is approximately equal.
Yes, sir.
1x, 2x, 1.5x means approximately in that range, right? Okay. But for example, you are creating a gap which is extremely small, very small gap. In that situation, it will behave like a circular wavefront. It will behave like a point source. It will be creating circular wavefronts. Okay. Means you will be getting, excuse me, you will be getting wavefronts like this. Understood?
So does the
And if the
wavelength stay
gap,
constant here?
wavelength will still remain same. This distance, this distance, this distance, this distance, all four distances should remain same. Okay.
Okay. Okay.
Wavelength will never change in diffraction, always remember.
Okay,
Now,
sir.
if the gap is extremely small, then it will behave like a point source and you will be getting circular wavefronts. But if the gap is in the order of the wavelength, right, then you can see how the diffraction is going to be, right? Is it clear? Draw this image, draw these images. Will this might help you, or take the screenshot, anything, whichever is convenient for you. And do write down whatever I have told you just now in your own words.
Sir, is this available on your website also? The source.
Yeah, definitely it will be there on the
Okay.
website. But still, like, note taking is a habit, something we should keep note of whatever we are
No, sir,
studying.
like in case I forget something to write, so
Yeah,
I'll
yeah,
just.
everything will be there, don't worry. Shall I continue? Students?
1 minute, sir.
Acha. Shall I zoom some image?
Yes, sir.
Which one? Below?
So the top one.
So the cube, yeah.
See, one thing was very beautiful when the physical school was there, that uh, there was more number of students were attending the classes. And now again, when we started the online school, a lot of absentees. That's not good.
Noted, sir.
Okay. Have you noted this one as well?
Yes, sir.
Okay. Now here the picture. Okay, let me copy this. And there's one more scenario. Controls. Sorry, Control C. Control C. Okay. Another scenario. What we are going to discuss is I'm removing this. Okay. Now here the energy is traveling like this. Energy is going this way. Wavefronts are going like that. And if the hindrance is something like this, if the obstacle is like this, then what is going to happen? So where the gap is there, except that area, you will be having the same scenario. Let me draw it for you. Okay, Control C, Control V. So you will be having like this. But in this particular region where the hindrance is there, right, there you need to create a cavity, right? And rest everywhere it will go straight as it was going before. Yes. What will happen at the corner? At the corner, it is going to bend in this direction. It is going to bend in this direction.
So why is that?
Just a second. Because it is corner and wave will bend through the corner. As it was bending at the corner over here, that is the diffraction now. Here was the corner. Till this point it was going straight. In this region it was straight. At the corner it got bent. Correct?
Yes, sir.
So like that, here also at the corner it will get bent. And at very large distance, this effect will be minimized. Here there is a region where you will get a shadow. You know, shadow means there is no disturbance, no wave. So let us suppose like any small like creature is here over here, and now the waves are going. Won't that creature will be unaffected with the disturbance over here at the center, here very close?
Sir, I
Yes.
didn't get you.
Means if any, like these are the water waves, right? and here one obstacle is there, and here let's suppose a small creature like a very small fish or any other thing is there, right? That that creature will not experience any waves or any other thing in this area, in this shadow. This is called shadow. And how the waves are bending over here, you can see because of this hindrance, it is bending like this, right?
So then they eventually come back to as they were.
Eventually come back. Why they will come back? Here, wherever there is a gap, right, these waves are not passing through, right? Where there is no gap, wave is passing through there, and at the corner it is bending. So
Right,
here,
right,
here the movement is going to be very weak as compared to where there is no hindrance.
right.
This is also a part of diffraction. Okay. So one more diagram you can draw in diffraction. Let me know once you have noted so that we can continue from there.
Sir, noted.
Okay.
So the green one is the wavefront, right? Green line
Yeah,
in the
green one is the wavefront and black line is the direction of energy. Okay.
Okay, sir.
So describe how waves can undergo diffraction through a narrow gap. Done, students?
Yes, sir.
Describe the use of water waves to demonstrate diffraction. Done?
Yes, sir.
So reflection, let's check reflection, everything we are done with or not. Describe the formation of an optical image by a plane mirror and give its characteristic. Do you know how to draw an image with the help of plane mirror?
No, sir.
Okay, so let's do it here. This is how we draw mirror. Okay. And let's take an example of a ball. So there is a ball, right? Now you can draw two light rays. How do we see things? If the light falls on that object and light gets reflected from that object and goes into our eyes, right? Then on the retina, the image is formed, right? If somebody is blowing the torch on your eyes, you will only see the light coming from the light source. You won't see any object in the room, right? But if you project the torch on any object in a dark room, then first light will go there, it will get reflected from there, and after reflection it will go to your eyes, and there on the retina the image will be formed. Agree?
Yes, sir.
In 8th standard you might have studied this. Now we will consider two light sources, minimum two light sources from any object, and that too at different angles, right? This is the criteria. So let us suppose the first light ray, what I am projecting from here, this is the first light ray, okay? And like that, I will project another light ray from the same point at different angle like this. Is it clear,
Yes, sir.
students? Now we need to draw normal. So won't this be normal?
Yes, sir.
Yes, sir.
It's irritating sometimes. Okay. Always remember, whenever you are drawing the normal, it should be always dotted lines. This is the normal. Now, what is the law of reflection? What is the law of reflection? Anybody?
So reflected ray, incident ray, and the normal all lie on the same plane.
Yeah, this is the second law. What is the first law?
Sir, angle of incidence is equal to the angle of reflection.
Very good. Angle of incidence is equals to angle of reflection. Please check whether it is promising angle or not.
So promising angle as in?
I means it is looking like this angle delta I and this angle delta R, they are looking equal or not? I'm not using protector over here, right? I'm just doing randomly. So is it looking like same angles or not?
So more or less, yes.
Okay. And now I will draw for here. Are they looking equal? You will be
Yes,
doing
sir.
it with the help of protector only. Here delta, sorry, angle I. This is angle R. All right. So what you have done? Two light rays you have projected on the mirror at the different angles, right? And then what you will do? So you can see these two light rays are never going to meet each other, right? Will never meet each other. Excuse me. Is it looking like straight line or not?
Yes, sir.
Everybody?
Yes, sir.
थोड़ी सी गड़बड़ है यहाँ पे. A small error, right? I think. Right, a straight line. But will the light ray will pass through the mirror?
No, sir, it will get reflected.
It will get reflected. So what I'm drawing over here, that is the virtual light ray. Virtual light ray will always be drawn with the dotted lines. Okay. Real light rays, actual light rays will be always solid lines. Virtual light rays will always be dotted lines. Right. Here at the point of intersection, you will get the image. So you will be having its image over here. Okay, understood?
Yes, sir.
Yes, sir.
Okay. Now, few more important points. The distance of the object from the mirror will be equal to the distance of the image from the mirror. Got it? This distance d will be equal. And this is how there is the image formation in the case of a plane mirror. I want you to draw this diagram yourself. This diagram should not be copied. It should not be taken screenshot, will not help, right? Unless you draw this image yourself right now in your notebook without looking at the screen, right? You will learn. Otherwise, in real time, you will forget. Right now, you are thinking that no, you will not forget. But what will happen? You will do mistakes. I've seen enough number of students doing mistakes in such diagrams. So everybody uh, make a diagram, turn on your camera, show me your image, and then we will continue from here. You have to
Sir, I
draw this
made the
image.
diagram, but I haven't like made the dotted lines.
तो दूसरा बनाओ, फिर से बनाओ.
Yes,
Yeah.
sir. Same. Okay.
Just raise your hand once you are. Excuse me. Once you are done. Excuse me. Arohi,
Yes, sir.
making diagram.
I am.
Good. Gul,
Yeah, sir.
make sure we are not wasting our time, huh? So do it fast, thoda sa. Very good. Abhijay is done. Arnav is done. Keep doing, keep doing, keep doing. Three students done. When you will come to the physical class, I will look at the diagram and you have to complete your all notes. I hope you all remember this. Keep keep maintaining notes. At last moment, that is students.
Yes, sir.
Shall I continue? Tanish, done with the diagram?
Sir, my light.
Not audible, Tanish. Aryan, will you continue?
Sure, sir.
Who's that? Sir, can you hear me? No, Tanish, you are not audible, beta. Recall the use of law, angle of incidence is equals to angle of reflection, done, right? Recognizing these angles are measured to the normal. Always remember angle of incidence and angle of reflection. You will always measure from the normal, not from the mirror or not from the surface. From the surface, whatever angle is, that is called glancing angle. Excuse me. Okay, that will be called
Glancing.
glancing angle. Okay. Perform simple constructions, measurements, and calculations for reflection of plane mirrors. I guess we did decent number of questions, including angle of deviation as well, and we included
Yes,
two
sir.
plane mirrors as well, right? So we have completed this, right?
Yes, sir.
Everybody agrees. Everybody agrees to me.
Yes, sir.
Okay. Let's go to refraction. Interpretation and describe an experimental demonstration of the refraction of light. Okay, refraction. This image formation, did I teach you this image formation?
Sir, I don't think so.
No, sir.
Okay, just give me a second. So we did a part of refraction. We have completed sine I upon sine r is equals to n. And instead of that, I hope you all remember that. Just a second. We did n1 sine theta 1 is equals to n2 sine theta 2, right?
Yes, sir.
Yes, sir.
This is done. This is done. This is done. This is done. Any doubt in 1, 2, 3, 4? Anybody? Any
No,
doubt?
sir.
What are those criteria? So, whenever the light ray, first criteria, you need to note down. The light ray which is moving from denser medium to rare medium. Okay, if I say this is air and this is water, its density, optical density is 1 and its optical density is 4 by 3 or 1.33. So tell me which is denser?
Water.
Water.
Can I draw the light ray like this?
So is it like when the light goes from denser to rarer, it moves away from the slope?
Now you are not audible. You aren't audible right now, beta.
Hello, sir, can you hear me?
Now we can hear you.
So is this like denser to rarer moves away from the slope?
Excellent. Yes, we cannot draw.
So we have done this then.
Yeah. No, I don't think so. Wait, I don't know.
So we have
Reflection
done
is
this.
We have done this though last class. I think
Oh,
before.
okay, yeah, we've done that.
done. I'm not teaching you refraction right now.
So it's like that, right? When it goes from a denser to a rarer medium, then it moves away from the normal. And when it's from a rarer to a denser medium, it moves towards the normal.
That is refraction. Now we are doing critical angle. Now we are doing total internal reflection.
Okay.
In refraction, light can go in both ways. In that refraction, it can go from rare to denser medium also, denser to rare medium also, right? Both way light can travel. Hello?
Yes, sir.
Students, am I audible?
So you keep lagging in between.
Acha, some internet connectivity, I guess. Just give me a second. So what is the code of the class for joining? Joining code? VOR. I got disconnected from other device.
P, F, J, H, and Q. So can you hear me now?
I can. P,
So
F,
P,
J,
F, J, H, and Q, V.
M, Q, V.
Yes, sir.
Okay. Okay. Now, let us suppose here in this case, the light ray was going from denser to rare medium, and I have taken this point. I have taken this point from here. Okay. So what will happen? This is angle of incidence and this is the angle of refraction. Okay. From the same point, I am projecting another light ray from the same point, but at different angle, right? So will it pass this way? The answer is no.
No, sir, it will bend a little bit.
It will bend away from the normal. What will be its angle? It depends on what?
So the medium is going from, and
This is theta
So
1, this is
if the
n1,
medium goes from
this is
denser to rarer, it will go towards the normal, and if it goes from
yeah,
rarer to denser, it will move away from the normal.
right.
but
So
I think he said the
let's
opposite.
do
Rarer to denser is
towards the normal, denser to rare, away
away
from the
from the
normal.
normal.
Okay. Now, at some point of time, what will happen when the light ray will be projected at some angle, right? You will get angle of refraction as 90°. How you calculate angle of refraction? From normal? At some point of time, the angle of refraction going to be 90°. Yes or no? Because it has to move away from the normal.
Yes, sir.
Let's do some maths. Okay. So here this is n1 and I am taking this in the first case. I am taking this case first, right? So n1 is equals to 1.33. Theta 1 is equals to 30°, right? N2 is equals to 1. That is not going to change in any case. What will be theta 2? Question mark. Okay. Can we do this? Yes. N1 sine theta 1 is equals to N2 sine theta 2. N1 is 4 by 3 multiplied by sine 30 is equals to N2 is 1 sine theta 2. Right? Yes or no? 4
Yes.
by 3
Yes,
multiplied by 1.2 is equals to sine theta 2, and you are getting 2 by 3. Sine inverse 2 by 3 is equals to theta 2. What is theta 2? Put in the calculator. I have calculator. I'm going to put shift sine inverse 2 by 3.
41.81.
41.81. So theta 2, we got 41.81 degree, right? Okay, this was the first case. In second case, let us suppose I am taking theta 1, this theta, theta 1 is equals to 45°, right? Now let's find theta 2, okay? So again, n1 sine theta 1 is equals to n2 sine theta 2. N2 is 1. So theta 2 is equals to sine inverse n1 sine theta 1, right? N1 is 4 by 3 sine theta 1 sine 45°. So first sine 45, I got 0.707 multiplied by 4 by 3. I got 0.9428. I hope everybody got the same. Shift sine inverse answer. I got the answer as 70.52. How much? Yes or no? 70. Everybody got the same answer?
Sir, I understood the numerical part, but I didn't understand any of the angles and the diagram I didn't understand.
First diagram is this. Second diagram is this.
Yes, sir. So can you re-explain the bending part?
Third diagram is this. Bending is simple that when the light ray goes from denser medium to rare medium, it moves away from the normal,
Yes, sir.
right? So by doing this at some point of time, the angle of refraction will become 90 degree, right?
Hmm.
What will be that point? So let's suppose I am taking 48 degree now. Theta 1 is 48
48.
degree. Third situation.
So shouldn't it be 70.53?
अच्छा ठीक है भाई 3 ले लो. Okay. This is not the my matter of interest. This and this. My matter of interest is 90 degree. When we will get 90 degree. So we can get that angle, but I want to do it forward way, not backward way, right? So here you see when you kept theta as 30, you got 40, right? 30, 40. When you kept 45, you got 70, right? Now I am increasing it to 48. Theta 1 is 48 degree. Now what I'll do? 4 by 3 multiplied by sine 48, sine inverse, right?
Yes, sir.
Sine 48, I got 0.743 multiplied by 4 by 3, and I got
So
0.99. Expressed
82.24.
sine inverse answer as 82.24, right? So here you got theta 2 as 82.247, means 25, right?
Yes, sir.
Okay, means somewhere little more than 45 degree, right? You can get 90 degree as the angle of refraction, right? What will be that angle? So do it reverse way. How? So n1 sine, now we don't know theta 1, right? N2, I know sine theta 2, that is 90 degree. So let's find which will be that angle. So 4 by 3 sine theta 1 is equals to sine 90 is 1, and this is also 1. I'll keep 1 over here. Sine theta 1 is equals to 1 divided by 4 by 3, which will turn out to be 3 by 4. Theta 1 will be equals to sine inverse 3 by 4. Just simply put the value, shift sine inverse 3 by 4, and you are going to get 48.59. Yes or no?
Yes, sir.
Yeah,
Means
yes.
if this angle is 48.59, then you will get angle of refraction as 90 degree. Are you getting? Are you getting till here? Students, yes, no, sir, फिर से बताओ, कुछ तो बोलो. Tell me,
So can you
are you
repeat
getting this
that? I
point?
don't understand.
See, this formula you know.
Yes, sir.
I am saying angle of refraction I want 90 degree. Means this angle I want when the light ray is passing like this. ऐसा.
Mm-hmm.
A light ray which should pass like to the surface. So at that point, from the normal, when we calculate this angle will be 90 degree, means angle of refraction is 90 degree, right?
Yes.
N2 is air, so refractive index is 1, right? N1 is 4 by 3 refractive index of water. I want theta 1 value. What is the theta 1? So theta 1 will be equals to, this will be 1, 1 divided by 4 by 3, 3 by 4. Sine inverse 3 by 4, theta 1 will be equals to 48.59 degree.
And sir, where did the sine 90 go?
Sine 90 is 1 na beta.
Acha, okay.
Sine 90 is 1.
Oh.
Understood?
Hmm.
Means, now this is the point of interest. This particular angle, when the angle of refraction becomes 90 degree, is called critical angle. Likho. The angle of incidence at which the angle of incidence at which the angle of refraction becomes 90 degree, the angle of refraction becomes 90 degree, that particular angle of incidence is called critical angle. Now, critical angle for water air case, water air, the comparison is what? Water and air, right? So the critical angle IC is equals to 48.59 degree. So light ray will graze the surface. Angle of refraction will become 90 degree. Excuse me. Is this portion clear?
Yes, sir.
Jahanika?
Sir?
Jahanika, is it clear?
Yes, sir.
Okay. Now what will happen if I project the angle of incidence at 50 degree? या बोल दो 48.7 degree. What will happen then? Will there be any refraction? And the answer is no.
So if angle of incidence is 90.
If angle of incidence is greater than this critical angle, there will be no refraction. Light ray will not be able to cross the boundary. If the angle of incidence will be more than critical angle, so like in this case 48.59 degree, and that time the light ray is grazing the surface. If I increase this angle of incidence, means if I take it here, so this angle is definitely more than 48 degree, and in this case light ray will not be able to cross the water boundary, right?
Right, sir.
That time you will be following, and you will be following law of reflection. Angle of incidence is equals to angle of reflection. So this is called total internal reflection, TIR. Now when I started this topic, you all started saying, sir aapne padha diya hai, right? So tell me whether I taught this before?
No, sir.
No.
Yes.
So have patience. Sometimes some background knowledge is also needed to continue. Yes, Aryan, tell me.
Sir, can you please repeat the definition of total internal refraction?
When the angle of incidence is greater than the critical angle, when the angle of incidence is greater than the critical angle, we will be having total internal reflection. Means then angle of incidence will be equals to angle of reflection. How the light ray will go? It will go like this. What does it mean? If a fish is over here, if there is a golden fish, over here and you are swimming right here, right? And you look at the surface on the top, you are looking over here, you are looking here, right? You will be able to see this fish. Your eye is this, right? And you are looking at the surface. You are looking top, ऐसा ऊपर देख रहे हैं, right? And there you are able to see a fish which is over here, like mirror. We understand? So how it will look like to you? It will look like the fish is, so इसको अगर like I approach it this way, so it will look like to you the fish is over here. Do you understand?
Sir, can you repeat that?
I am saying this is when angle of incidence is greater than the critical angle in this case, right? You will be getting total internal reflection, means the light ray will go like this. So for example, you are over here and you are looking at the surface of the water. Inside the water you are, and you are looking at the surface. So it will look like to you that this fish is actually over here. So total internal reflection, you understood?
Yes, sir.
Let's find the critical angle in the case of glass and air. What does it mean? It means like a light ray in the glass. Okay. This is a glass slab. And let's suppose a light ray started from here, right? And you know there will be refraction, correct? Like this, yes or no?
Yes.
Hmm? So this is the scenario. Okay. What we are finding out? We are finding out the critical angle. So what is the condition of a critical angle? Anybody will repeat?
So when the reflection angle is 90 degree, when the angle of reflection is 90 degree, the angle of incidence at that time.
Excellent. Yes, that is the criteria. Okay. So means this angle of reflection becomes 90 degree. This is the critical angle. Now we no need to do the same process what we did earlier. I already know this theta 2 is 90 degree, right? I know this refractive index N1 is equals to 3 by 2 or 1.5. I know this N2 is air, so it is 1, right? We have these informations. What we are finding out? We are finding out theta 1, which is the critical angle. How do we do this? N1 sine theta 1 is equals to N2 sine theta 2. N1 is 3 by 2. Sine theta 1 we are looking for is equals to N2 sine theta 2. N2 is 1 here, right? Theta 2 is 90 degrees sine 90 degree, right? Is equals to 1. I can write theta 1 is equals to sine inverse 1 divided by 3 by 2 or sine inverse 2 by 3. We will get theta 1. Yes or no?
So 41.81.
41.81, yes. So theta 1 is 41.81 degree, right? So higher the density, higher the optical density will be, lesser the critical angle will be. And that's why in diamond, where the optical density is really very high, the critical angle is extremely low. And that's why whenever the light enters in the diamond, it it stays, it stays there, there is a lot of total internal reflection, and because of that diamond shines a lot. So this is one reason. So 41 degree, 41.81 degree, right? So this is the critical angle for the combination of air and glass. This will only happen when the light ray is trying to go from denser medium to rare medium. This is called critical angle. Now, if your incident angle is greater than this critical angle, there will be no reflection, there will be total internal reflection, where angle of incidence is equals to angle of reflection. Do you understand?
Yes, sir.
So this is called TIR, total internal reflection. So are you ready for questions? I think we don't have much time, right? We are done for the day.
Right,
So
sir.
in next class we'll be doing questions. Again, after repeated reminders, many of the students have not submitted their test wala assignment. Seriously, zero. Confirm zero. I can't do anything. Tell your friends. I waited enough. So see, the critical angle is done. Total internal reflection is done. Critical angle done. In next class, we will take some examples of this critical angle, right? And we will study about the optical fiber. So we'll start from here. Okay. So that's it. Take care, everybody.
Thank you, sir.
Thank
Bye.
you, sir. Bye, sir.
Excuse me, sir.
Yes, Arohi.
For the extra physics class, I asked the entire class, but no one was available during that time. Um, I think I missed out on three physics classes, and I think we covered a lot. Um, how do you think I can catch up?
Okay, then for you only, like let me, like if you would have reminded in today's class only. During the class, I would have asked the entire class. So let me ask to the entire class. I am sure that many students will be there, and we will be having the session before examination definitely.
Okay.
Okay,
Also, I forgot to save the link for your website again. If you can just
I will
forward.
share. I will share.
Thank you so
Okay,
much.
chalo. Take care, beta.
Okay. Okay. Thank you, sir. Have a
Bye.
nice day. Bye bye.
Bye, beta.